So we'll start out with chapter 1. It's a good place to start. This chapter is about matter, measurement, and problem solving. So the author poses this question: what do you think is the most important idea in all of human knowledge? Now, you don't have to answer that out loud, but just think about that for a couple of seconds. The most important idea in all of human knowledge. We could probably have a really long debate about that one. Well, if we limit ourselves to scientific answers, which is appropriate because this is chemistry class, it would probably be this: the properties of matter are determined by the properties of molecules and atoms. So the properties of matter are very important to us. The properties of a plastic bag: will it hold the groceries? Will it decompose in a landfill? Those sorts of properties are very important to us. The properties of matter that we can observe come from the behavior of the atoms and molecules. The atoms and molecules are different, the matter is different. And so if we understand matter at that molecular level, then we have a lot of control over the matter, and we can make a different sort of plastic bag that will degrade in a landfill and won't just stick around for thousands of years. So in chemistry, we're going to learn about the atoms and the molecules, those basic levels of matter. So what are atoms? Well, atoms are the submicroscopic particles that are the fundamental building blocks of matter. Submicroscopic, they are too small to be seen, even with the most powerful visual microscope. I think of atoms as being a lot like Lego bricks. You guys ever played with Legos? My kids have an enormous collection of Legos. And there's little individual bricks, right? And you can build all kinds of things out of them. But when you take a Lego structure apart, you can take it apart into those little bricks, but you can't take the bricks apart, right? So the atoms are like individual Lego bricks, and they can be combined together to make other things, but you can't take the atoms apart. So free atoms are rare in nature. Usually atoms are found combined with other atoms in what we call molecules. So this is an example here. Still got an issue with the pointer. So this is an illustration of a water molecule. In a water molecule, there is one oxygen atom and there are two hydrogen atoms, and they are stuck together in this configuration. All water molecules are going to look the same. They all contain two hydrogen atoms and one oxygen atom. So those combined atoms are called a molecule. The properties of that water molecule determine the properties of the water itself. So a glass of water is going to have gajillions of those water molecules. If you change the properties of the water molecule by changing the molecule, you change the properties of the water. So here we have an example. Here's that water molecule. What if we just sneak one more oxygen atom in there? So this is hydrogen peroxide. It's got two oxygen atoms and two hydrogen atoms. That's not a huge difference, right? But the properties of water and hydrogen peroxide are vastly different. Hydrogen peroxide in a dilute solution is what you can use to clean out a cut. You put it on the cut and it fizzes and kind of stings a little bit, and it kills any bacteria that might be there. Water's good for washing a cut, but it's not going to kill bacteria. There's a joke. Two people walked into a bar, and the first guy says, "I'll have a glass of H2O," and the second guy says, "I'll have H2O too." They both drank their drinks, and the second guy died because he asked for H2O2, hydrogen peroxide. You drink hydrogen peroxide, you're gone. So if we want to understand matter, the substances around us, we have to understand the molecules and atoms that compose them. And that's the goal of chemistry, is to understand atoms and molecules. So one definition of chemistry would be the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules. The illustrations here are showing graphite, which is in your pencil lead, and a diamond. Both of these substances are composed of carbon atoms, and yet their properties are very different. Graphite is slippery and black and soft and not worth very much, and diamonds are clear and very hard, and they're worth a lot of money. And the difference here is only in how those carbon atoms are connected to each other. They're both pure carbon. It's just how the atoms are connected.